Hi, and welcome to the 11th episode of the Sienna training series. I'm Kate Doubleday, and today's episode focuses on processing results in Sienna for both Sienna Ops and Sienna Dyn. So Sienna is an open source platform for power system modeling, simulation, and optimization with three core applications. Sienna Data focuses on efficient data input, analysis, and transformation. Sienna Ops enables system scheduling simulations by formulating and solving optimization problems like unit commitment, economic dispatch, and power flow. Sienna Dyn enables system transient analysis, including small signal stability and full system dynamic simulations suitable to represent electromagnetic transients. Each of these three applications is enabled in a combination of packages in the Julia programming language. So today we're focusing on a couple of different packages across both Sienna Ops and Sienna Dyn. The majority of the video will focus on Sienna Ops, including how to access results in PowerSimulations, how to do some post-processing in PowerAnalytics, and some plotting capabilities in PowerGraphics. We'll also look briefly at the very end about some ways to access results in PowerSimulationsDynamics for Sienna Dyn. So the first step in results handling is just to get access to the results data. There are a couple of different functions to do that based on what type of problem you've just solved in Sienna Ops. And these functions are all available in PowerSimulations.jl. So if you have just solved a decision model, use optimization problem results on a solved model to access those results. For simulations, it's a two-step process. First, you get access to the results of the simulation in total using simulation results, but then you need to access individual stages within the sequential stages of a simulation using get decision problem results. You can both call simulation results on a solved simulation in one instance of Julia, but you can also call it on an output directory. So this is useful if you're going to run a bunch of simulations and leave and come back and do the results post-processing later. You can read them all in from where they're saved during the simulation process. So those are all available in PowerSimulations if you're looking at a single simulation. If you're doing scenario comparison, there's also a useful function in PowerAnalytics called Create Problem Results Dict to load in the results from multiple scenarios. It does assume that there's a certain structure to the results directory, and if you don't have that particular structure, you can also just create this dictionary yourself. Let's say you've done this. You've gained access to the simulation results or decision problem results. What's the next step? So let's say we've read in economic dispatch results. If you print that structure, you'll see that it lists the expressions, parameters, and variables included in the output data. You can use a couple of different functions available in PowerSimulations to get data frames and dictionaries of the output data, including the optimizer statistics, but you can also read in these variables, parameters, and expressions by name. There's also options to read the duals. So these will all grab the realized variables, parameters, and expressions from a sequential simulation, excluding the look-aheads in any given stage. So if you're interested in also seeing the look-ahead values, there are options to read those in as well, just without this realized part of the name. So far, we have access to the data. We'll end up with some either dictionary or data frames, and that kind of concludes the accessing functions that are available in PowerSimulations. The next step is using PowerAnalytics to calculate summary statistics on those results, data frames, and dictionaries, filtering for the data of interest and doing those calculations over different timeframes. There are three concepts we're going to introduce before we show an example of using PowerAnalytics. So those are component selectors, metrics, and data frame, using the data frame metadata for further aggregation. Component selectors are a feature which allow you to repeatably and flexibly define what part of a power system you want to analyze. So this is a bit of an advanced capability. The primary use case for component selectors is repeatable multi-scenario post-processing analytics. There are also the standard get components methods, which are our go-to basic approach to filter for certain components in a system. But component selectors give a bit more flexibility to filter, group, and aggregate components, and then reuse those filters across multiple data sets for easy comparison across scenarios. So some examples would be, all right, I want to calculate something on all of my solar plants and separately all of my wind plants. Or I'd like to calculate something for each solar plant that is at least 15 megawatts. You could also do something like, I want to do a geographic aggregation. So I would like to look at all the loads in a particular zone altogether. Once you have defined a component selector of what you want to grab, the next thing is to select a metric. So that's what you want to compute on those components and how you want to compute it and aggregate it across space and time. So some examples would be, I would like to look up the power output from all my generators, and I would like to sum it across, get the sum across all generators for every time point in my simulation. Or I'd like to get the sum across all time for one generator, or I'd like to get the sum across both, the total geographic temporal aggregation. Other options with metrics are to do things like different summary statistics. So that could be, I want the sum, I want the mean, I want the weighted mean, I want the minimum. Those are all things that you can define. A metric, once you calculate a metric, it will output a data frame that includes metadata for additional time aggregation and plotting. So that is things like, I'd like to now look at the power output to get the peak across every day of the week or every month of the year. In addition, those data frames can be easily plotted and the metadata can be used for labels. So coming back to metrics, there are currently 25 options predefined in PowerAnalytics that include both time-varying and time-independent metrics. So the time-varying metrics, which can be calculated for any time point in a simulation, are things like, all right, what's the curtailment for my renewable generators, battery stored energy, generation production cost. The time-independent metrics include things like, what was the memory allocation for this simulation, the solve time, objective value, and total system cost. So for any of these metrics, you can quickly get those summary statistics, average, mean, min, max. You can also modify a metric with a different aggregation method to switch between those summary statistics. And if you want to calculate something that isn't covered by these 25, you can also easily write your own custom metrics. So let's look at an example of how this works in PowerAnalytics. First step, we're going to define a component selector. So this again is the filter for what components I'm most interested in. So in this case, you could make a selector that says, I want to filter by a couple combination of things. The rating is at least 15. The type is thermal standard, and I want to group it by the prime mover type. Once you've defined that selector, you select your metric and calculate it. So in this case, we're saying, all right, let's calculate, I want to calculate the total active power from all of my thermal generators that are larger than 15 megawatts grouped by their prime mover. And so for every time point, we can see that sum for combustion turbines, combined cycles, etc. This data frame includes the additional metadata that we can use to do additional time aggregations. So we could say, all right, now I want to see it grouped by day of the week. And so we can see those totals here for days 1 through 7. And then this is something that we could easily plot and use these labels for plotting. So from this type of framework with Power Analytics, you can easily set up automated results handling, either for an individual simulation or for summary statistics across multiple scenarios, multiple simulations for quick comparison. There is a written tutorial online that shows that scenario analysis, and we'll link that in the video description for you to take a further look. So far we've covered how to get access to the results, how to do this data post-processing. The third thing we want to cover for Sienna Ops is PowerGraphics. So this is a plotting package built on top of plots.jl, that has some basic structures for common plots that are useful in power systems analysis and also just sanity checking. So since this is built on top of plots, it has all the same customizations available, different colors, axis labels, interactivity versus static backends. So as an example, we currently have options both for static backends using GR as well as interactive plots using Plotly.js. This is just a screenshot, but this can make interactive plots with tooltips and different ways of sort of selecting and filtering the data. There are additional keyword arguments to make common plots. So here we're showing the difference between our built-in demand plotting function, which automatically does line plot for every load, versus a couple options to aggregate things by area, summing all loads within an area, and then also switching from a line plot to a stacked plot. In addition to the demand plot, we also have a built-in dispatch stack plot with similar keyword argument options to switch between sort of a smooth line plot, a stair plot, and a bar chart showing total energy. These are built in with color palettes to separate the generators by technology type, but this again could be customized with a different color palette for a different technology grouping of interest. So the demand plot and the fuel plot are really useful for quick sanity checking. If you're looking for developing your own plots for presentations that go beyond these, there is a sort of a generic plotting function available, but at that point you probably would want to look into building your own custom plots. Importantly, PowerGraphics is currently compatible with Power Simulations version 4.0 and earlier. We are switching to 5.0 sometime this fall of 2025, at which point there will be a break in compatibility. We're hoping to expand PowerGraphics functionality in the future and make it compatible again, but there will be that break. So far, everything we talked about was applicable for Sienna Ops. I just want to finish this video with a quick note about Sienna Dyn. So as of Power Simulations Dynamics version 0.15, the best functions available to access results are listed here. That includes a read results function to retrieve the results from a solved simulation. Currently, this cannot read results from file, unlike Sienna Ops. So you would need to load the results from a simulation right after you solve it. And from there, call get state series, voltage magnitude, voltage angle, and active power, so most common results reading functions to get those data. We eventually want to do something like PowerAnalytics and PowerGraphics for Sienna Dyn, but currently we just have the results reading capability, so you would need to just write your own custom plot functions to view those data. We'll put another example that has some results reading in the video description for Sienna Dyn. So at this point, next steps would be taking a look at those two tutorials in the video description for Sienna Ops and Sienna Dyn to get a bit more detail. And we hope this was helpful. Thanks very much.